All right, guys, so this is a pretty introductory lesson. Kind of a couple goals from the lesson today. We need to be able to identify different segments and lines in relation to a circle. This unit is all about circles and special ways that you can find different parts of circles, ways that you can find the lengths of segments and the lengths of angles and arc lengths and different things like that. Like I said, today's going to be pretty introductory as far as how deep we go. We're going to look at several vocab pieces, and then we're going to look at just a couple simple theorems that are pretty easy to apply. I will, just as a little prerequisite, say that you will want to try to remember some of your quadratic rules, okay? There will be some times, especially today, where we will see some x squareds or r squareds or different things like that we'll have to deal with. So just try to recall that into your brain as we are kind of working today, okay? All right, so you probably know several of these already. Well, not several. You probably definitely know radius and diameter, I hope. Chord, secant, and tangent. Chords and secants are kind of the two more challenging ones to keep straight. So what I want you to do is I'm going to give you a quick 30 seconds in your groups. So over here we have the chord labeled, the secant labeled, and the tangent labeled. Okay? So I'm not worried about radius or diameter. I want you to talk about the difference between a chord, a secant, and a tangent. Try to just verbalize it to each other, and then we'll write down some semi-formal definitions. Go ahead. All right, what did you guys come up with? What is a chord? Okay, what's the difference between a chord and a secant? Good. So a chord is a segment, a secant is a line. What do the endpoints of a chord have to be? Or where do they have to be? On the circle, right? So on the circumference of the circle. Okay. Whoa. So let's go over here to chord. So segment with endpoints on the circle. Okay, so it's a segment with endpoints on the circle. The difference between a secant, okay, a secant is a line that intersects the circle twice, right? So this one's a line. Why is it messed up? There we go. Line that crosses circle twice. Okay. All right, a tangent. Did you get time to talk about a tangent? So what's the difference between a secant and a tangent? Good. It's going to cross or touch the circle at one point. That makes it a tangent. Did you notice anything else about the tangent? Yeah, so in order to be, and that's not special, it's always that way. In order to be a tangent and only touch the circle once, it's got to be perpendicular to the radius or diameter. Okay? So we're going to say line that touches once. I don't think we need to go over radius or diameter. At least I hope not. Okay, so those are the pieces of vocab that we need. Okay, if you know those, you're pretty good for now. Okay, so then we have some coplanar circles and common tangents. So these are a couple more pieces of more in-depth vocab. Okay, so coplanar circles just mean that they intersect in one point, or sorry, no. Coplanar just means that they lie on the same plane, okay? They can intersect at 2 points, 1 point, or no points, okay? They don't have a special name if they intersect in 2 points. If two circles intersect at 1 point, that means that they are tangent circles. They have a common tangent, okay? And then if two circles have the same center, they are called concentric circles. Okay, so you might see those things in a problem, like if it's describing there are two concentric circles, you know that they have the same center. Or if you have two tangent circles, that means that they are touching at 1 point on the same point of tangency. Okay? Oh, I guess that one wasn't covered up there, but a point of tangency, if you ever see that, the point of tangency is just the point at which the tangent touches the circle. So it's the point where the circle and the tangent touch. That's the point of tangency. Okay. All right. Let's go ahead and, oh man, I put this in where we have, it's all on the same page. Let me see if I can get rid of this page. Yeah, there we go. Oh, can I get rid of this stuff too? Okay, here's page 2. Okay, so we have a couple theorems. Okay. So we have a tangent line to circle theorem. So it says line M is a tangent to circle Q if and only if it's perpendicular to QP. So as I told you on the first page, a tangent has to be perpendicular to the radius and or diameter. Okay. So what does that mean? What does perpendicular really mean again? They cross at a right angle. That should help you do example 1. Ready, set, go. So try example 1. Actually, do example 1 and example 2. And then I'll stop you and we'll go over them together. Do example 1 and example 2. Go ahead. Okay, so working through example 1, we kind of talked about off the recording. We talked about figuring out what the right angle is. Okay. Because we know if it's a tangent, this has to be a right angle because ST has to be perpendicular to TP. That would make this triangle that's shown a right triangle. So if we can prove it's a right triangle, we can prove that's a right angle. So my two legs would be 12. So I'd have 12 squared plus 35 squared equals 37 squared. So 12 squared is 144. You guys are going to have to help me out. What's 35 squared? Hey?
1,225.
Okay. And what's 37 squared? 13 what? 60? 9. So then do I check, do those add up to be 1369? And yes, they do. So then I know that that is a right angle. I know it's a tangent. So I would say yes, it is a tangent. Okay. Example 2, similarly. Oh, what? Whoa. What's happening? Get my right angle back there. I think I got to group it. What just happened? Did that make it work? Oh my goodness. Sorry, they updated Notability or explain everything. Oh, there we go. Group. Sorry about that. Okay. All right, so now in this example 2 diagram, it says B is a point of tangency, so I know that's a right angle. So I need to find the radius, okay? So my two legs would be 80. Okay, R. And then what's the hypotenuse? 50 plus R, right? So I need 50 plus R. Quantity squared, right? So 80 squared. Just get a calculator so I don't have to keep asking you guys. So 80 squared, there's my squared button, is 6,400 plus R squared equals, and over here I need to make sure I'm doing 50 plus R oh my gosh, times 50 plus r. Okay, so I do 50 times 50. What's that, 2,500? Plus 50 times r, so that's 50r. Plus r times 50, so that's 50r. And I'm running out of room, plus r times r, so that's r squared. So I have 50r. No, I messed that up, sorry. I have 2,500 plus 250r, so that'd be 100r, plus r squared. Okay? So make sure you do your double distribution properly. Okay? From there, since I see an r squared on both sides, I really like to see that because that's going to cancel out my r squareds. So I'm going to subtract r squared. That's going to cancel. I still see an r over on the right, so I'm going to bring this number over here to the left. Subtract 2,500. Okay. So I'm left with 3,900 equals 100r. Divide by 100. And I end up with the radius is 39. Okay, so the radius is 39. Any questions there? I know it seems like a lot of work. Occasionally, depending on how the problem's set up, sometimes you might have an r squared that you have to deal with. Okay, and remember to recall your quadratic solving skills. You can either do quadratic formula, factoring, or solve by square roots, whatever is appropriate and available to you. Okay, all right. We have one more theorem we need to look at. This one is nice and simple. If two tangents cross at the same point, so if SR and ST are tangent segments, so they're both tangent to the circle, they meet at the same point, both of those segments have to be congruent. Okay, so both of the segments have to be congruent. So a very, very simple problem is example 1 then, right? So RS and RT should be congruent segments because they're both tangents that meet at a single point. So that means very simply I can set 28 equal to 3x plus 4 and solve. So subtract 4, divide, and I end up with x is 8. Okay? Nice and simple. Okay, any questions? Let's go ahead and do 6, 7, and 8. So go ahead and do 6, 7, and 8 together with your groups. I'll give you some time to work and then we'll go over the answers. Go ahead. Okay, so here's number 1. Some of you got a little bit thrown off thinking that the sides were 2, 3, and 4. Okay, recognize that the 2 does not label the entire hypotenuse. The 2 just labels a section. Remember, a radius is a radius is a radius. It stays the same throughout the circle. So I can pull that 3 down as that section of the hypotenuse, and then I know the hypotenuse is 5. So it's a 3, 4, 5 right triangle. I can prove it with Pythagorean theorem. Yes, that is a point of tangency. DE is tangent. Okay? Any questions on that one? All right, number 2. It tells me ST is tangent, and I need to find the radius. Oh, why did my screen move? Okay, technical difficulties. We're good now. So I set up my work for my right triangle. One leg is 24, one leg is R, and then the hypotenuse is R plus 18. So you can see my written out equation up at the top. My work down below that. When I do R plus 18 quantity squared, I end up with R squared plus 36R plus 324. And then I go about solving from there. Luckily my R squareds drop out, and I'm left with R equals 7. Any questions on 7? Alrighty, last but not least, number 8. So it says points M and N are points of tangency. That means the two segments shown outside of the circle should be congruent. So I set up x squared equals 9. When I take the square root of 9, remember back to when we were doing quadratics, if you put the square root into the problem, you are responsible for the plus or minus. Because that x could be 3 or it could be negative 3, because if I square negative 3, it still gives me 9. Okay? So there are two possible x values. Notice that a negative x value would not mean a negative length, right? There's no such thing as negative length, but I could still include the x value of negative 3 because it's just an x value, not a length. Okay. Any questions? All right, rest of the time is yours for prep.